So we went yesterday over simplifying radicals, which should have been a bit of a review, but at the same time we added in the variables. Adding and subtracting radicals is actually pretty simple. It's basically like terms. Okay, and if you remember like terms, you have a question like this, we're looking for variables that are the same to the same exponent. Okay, and my suggestion to you always is whenever you see brackets, rewrite this without the brackets. So if I have plus negative 3x, that's going to become just minus 3x plus y minus 3. So now I look at like terms. I have 2x minus 3x, that's negative x. Negative 3y plus y, that's negative 2y. And 4 take away 3, that's plus 1. Okay? So when I look at radicals, how do I know if they're like terms? Okay? Like radicals have the same radicand, that's the number in the radical, and the same index. So looking at my first example here, what's the radicand? 5, so that's the same, and the index is the same. These are like. So then I just have to look at the coefficients. 9 take away 5. This is just 4 root 5. Pretty simple. And then it's not simple, because these are not the same radicand, but they are the same index. So that means maybe we should try to simplify to see if we can make them the same. So is there a perfect cube factor of 24? Yes, 8. Is there a perfect cube factor of 192? Well, let's think of my cubes. 8, 27, 64. Oh, 64 looks good. I can see 64 goes in 3 times. By the way, here's a little hint to you. A lot of times we're looking to see if we're going to end up with the same index, or sorry, the same radicand. And this one, does 375 have a perfect cube factor? Yes, 125. Okay, so let's continue the simplifying here. This is 2 cube root 3. This is 4 cube root of 3. And this is 5 cube root of 3. And now they have the same radicand, same index, and I can just add the coefficients. 2 take away 9 is negative 7. Okay, let's try this one. These are all square roots. Let's try to simplify them. This is 9 times 7. This is 4 times 10. Hey, by the way, can I only do 4 times 10? Would it be okay to do, I don't know, let's say 8 times 5? Would that be better? Well, no, because 8's not a perfect square. So I don't want to do that. Make sure that the first number you write is a perfect square. All right, and looking at that, I see some radicands that are the same. So this is going to be 3 root 7, 2 root 10, 3 root 10, and 2 root 7. And now if I look at like terms, I have 3 minus 2, so that's root 7. And I have 2 minus 3, so that's negative root 10. Okay? So that's what you need to be able to do. We're just going to make them a little bit trickier. We're going to throw some variables in, see if that makes it a little bit harder. Okay, the only thing there is we're going to have to talk about where is the variable defined. Okay, so if I look at this one, oops, what happened to my... Okay, so I'm looking here. these are all like terms. They all have a radicand of a, they all have the index of 2. So 6 plus 5 minus 11, this is 0 root a. 0 root a is just 0. But I need to state, what can a be? Well, it's a square root of a. A has to be positive. Okay, let's try the next one. Let's simplify. So this is going to be 25a squared. And what's left over? 2b. What's a perfect square in the second one? 4a squared. What's left over? 2b. So this is 5a root 2b minus 2a root 2b. Now, can I subtract or add that? Well, they have the same radicand, 2b. They have the same index, 2, so these are like terms. So then I look at the coefficient, 5a take away 2a is 3a square root of 2b. Okay, and now let's quickly talk about what can a be and what can b be. Don't look in the final answer. You need to look at the original question. So if you look at this question, you see that it's a square root, meaning what's inside has to be positive. Now a squared is always going to be positive, so a can be anything, because when I square it, it's going to turn positive. How about b? Well, b, if I put a negative in there, then what's in the radicand is going to be negative, so b must be positive. Okay, and we have one little glitch here. Notice that we took the square root of a square. Square root of a square. That means we should have put the absolute value here. Okay, now I'm not going to stress that, but just so you're aware. Alright, last one here. Let's try to simplify it. So looking for perfect cube factors. So 27p cubed. What's left over? Just q. And then there's an 8 there. Here, what's perfect cube factor? P cubed. What's left over? The q. So this is going to be 3p cube root of q plus 8p cube root of q. And if I put those together, I get 11p cube root of q. Alright, let's talk about what p and what q can be. Again, look at the original question. Well, since it's a cube root, that means it can be positive or negative. So I can just put negative infinity to infinity. Okay. Our last example, these are the same questions as the previous example, except that it already defines the variables for you. Okay, so we don't have to do that. It's just like one step out of the question. So we just have to collect like terms here. Is there anything that's like? Well, I see a root m and a root m, so 7 plus 5, this is 12 root m. And then I see a 2 root n minus 3 root n. This is going to be negative root n. All you need to do. Okay, let's look here. Anything like with the cube root of negative 3b? Well, this is a square root. That's not, oh, this one's like. So I have negative 7 cube root of negative 3b. And then this one happens to be like with this one. So I get 11 square root of negative 3b. Okay. Last one. This is a little bit more complex. We've got to simplify a little bit here. So is there a factor of 32 that's a perfect square? 16. A to the fourth means 2a's left over. Take away 2, and then we've got to simplify 45. That's going to be 9b squared. Leaves you with 5b. And then we're going to have 5b. What's the square root of 125? 25. Leaves you with 5b. And then minus 2a. Is there a factor of 72 that's a perfect square? Yeah, 36a squared, 2a. By the way, when you see a question like this, you should pause the video and always try it yourself first before you watch me do it. It's good practice for you to do it. Okay? So the square root of 16a squared, that's 4a squared. So this is going to be 12a squared times the root of 2a minus 6b 5b plus 25b, the root of 5b, minus, this is going to be 12a squared root 2a. Now, do we have any like terms? Is there anything like with 12a squared root 2a? Yes, that. That's 0. And then I'm going to have negative 6b root 5b, 25b root 5b. Those are like terms. Okay, and I end up with just 19b root 5b. And I don't need to say what a and b are because that's already been done. Okay? So let's give you some more homework. Make sure you do that.